everybody, and welcome back to another episode of Cellular and Wireless Unmasked. I am Martin Hevesy, and today I wanted to tackle a topic that's a little bit confusing for some, and hopefully we can clear it up. I want to talk about how fronthaul is different from backhaul. All sites have backhaul, but not all sites have fronthaul. Everything with fronthaul has backhaul. What are the differences? How are they similar? Let's jump into it. Okay, so before we get started with fronthaul, let's review what backhaul is. We talked about backhaul in a previous video when we went over the architecture of most modern cellular networks. Most cell networks have a network of cell sites, macro towers, building tops, rooftops, whatever they are, with equipment, your BTS gear at the base. All of these cell towers, every single one has an attachment to the MSO MSC, the mobile switching office or mobile switching center. This is basically what connects the cell network, the provider, AT&T, Verizon, T-Mobile, to the rest of the world. So you can make calls anywhere. These big offices, there's a number of them in each region, do a lot of that call processing. They check and make sure your phone's eligible to be on the network and so forth. But every single site that provides wireless services has some type of a connection back to this MSO, back to the switch. Today, most of these connections are fiber links. They are terrestrial, hardwired fiber circuits back in. They used to be copper, they used to be T1s. Any way they can get that connection back. In some cases where the connection, the backhaul connection wasn't possible, you had some outer lying sites that were mountaintop sites. They didn't have any hardwired facilities. They would use a microwave shop, so they would use a wireless link. So this section here is the backhaul for this site. So if you have a wireless link, it usually goes back to another site, and then this backhaul is the shared backhaul for these two sites or multiple sites. But backhaul is what connects macro cell sites back to the switch, the MSO MSC. This is backhaul, okay? And let's look at how that is similar, but also different from fronthaul. Okay, let's look at the basic architecture of a typical cell site. Your typical tower has the antennas at the top, and you've got your gear at the base. That can be inside a shelter, those can be outdoor cabinets. There's a lot of different ways to house that equipment. Legacy cell sites have all of the radios that generate the signal inside the shelter or in one of the outdoor cabinets, all the controllers, all of the filters. Everything is in this box. They call it the base transceiver systems, the BTS. And then everything gets plumbed to the top antennas via coaxial cables. In some cases, these cables can be quite long, they get quite large, they're pretty unwieldy. It's kind of difficult sometimes to run these large coax, large diameter coax up to the top of the tower. So we've seen kind of a gestation, a bit of a maturation of networks in recent years. And to help you understand what fronthaul is, I want to show you how things are changing. So instead of the radios and a lot of that signal generation taking place inside the shelter, the radios now have been moved up to higher on the tower. So what you'll see on some modern cell sites is you'll see a bunch of extra boxes higher up on the tower. Now, why do they do that? Why would they move the radios from down here where they're easy to get to way up on the tower? A couple of things. The radios now are much more robust. They are not as fragile as they used to be. It used to be the radio gear was really fragile. You couldn't get it wet. It had to stay within a very, very narrow temperature range. You couldn't get them too hot, too cold. Now they can sit out in the sun, they can get wet, and they still work just fine. So these radios can live up on the tower, and instead of having these long, lossy coax runs up to the antennas, now all you have is a short coaxial jumper to your antennas, and it works just fine. And instead of pulling expensive, large diameter coax that's really hard, there's a bend radius, it's difficult to get that up to the top of the tower, you need specialized tools, specialized testing. Now, all they do is from inside the shelter, they just run a power link and a fiber link to each of the radios. So it's a little bit easier to build a cell site because you're only running easy to manipulate cables and connections. Instead of all that coax, you still have your baseband, you still have your, you still have your connection, your backhaul to the MSO MSC, but this has taken a little bit different shape in modern times. Now, that backhaul is fiber, correct? We talked about that. In most cases, it's a fiber connection to the MSO MSC. The controller for these radios up on the tower, that's called a baseband unit, BBU, all right? So this BBU is usually connected to the backhaul to the MSC. This is kind of the demarcation between backhaul and front haul. The fiber that goes out from this baseband unit to connect these radios, that is your front haul. In most cases, this is single mode fiber, just the same as this link. Fiber is popular because it's got much more bandwidth capability, it's easier to deal with, it's much more reliable. So fiber is the medium of choice to connect the entire site back to the MSO via backhaul, but that baseband unit inside the shelter has fiber connections to these radios. That is your front haul. Now, there can also be a situation where you have small cell networks. You've got a light pole out somewhere in the middle of downtown, and it's got an antenna on the top and a couple of radios in the middle. We've talked about small cells in the past. These small cell radios still connect to a baseband unit somewhere within the operator's network. And that's typically a fiber connection back into the shelter, into that baseband unit. This fiber path is front haul because it's bringing that controlling link and all that signaling back into a shelter, back to that BBU. And remember, the BBU is that demarc location, that demarcated piece of equipment that defines backhaul from front haul. So depending on which way the signals, they're bidirectional signals, but which way they're going from the baseband unit defines whether it's front haul or, not to make this too confusing, this link here is backhaul, H-A-U-L, back to the MSO MSC. That's your backhaul link. And anything that connects from the baseband unit to these radios, that is your front haul, H-A-U-L. And then let me make this purple to help. Oops. That is your front haul. So this is fiber. This is fiber, this is fiber in most networks. The backhaul links and the front haul links medium is actually fiber optics, but it is this baseband unit, it is this BBU that is the defining piece of equipment that separates backhaul from front haul. So you will see modern cell networks with radios at the top. In fact, all of the good 5G, all of the good 5G millimeter wave, the high bandwidth, the multi-gig down, those radios and antennas are one, they're active radios antennas. Those use front haul from the shelter to the top of the tower, or if it's a small cell network where you got your 5G radios at the top of the tower, the top of the light pole, that fiber connection back to the shelter or back to wherever that BBU is living, that's front haul. So again, connection back to the MSO MSC, that is backhaul. Connection from that baseband unit to the radios, the top of the tower, from the baseband unit out to small cells, that is front haul. So that's it. Backhaul back to the MSC, front haul out to the radios. So that's the difference between backhaul and front haul. In most cases, it's still fiber optics. In most cases, it's the same exact kind of fiber, but they just do different things. So that connection to the MSO is your backhaul. The BBU is that device. It looks kind of like a switch. It can handle multiple radios. But that is the difference between backhaul and fronthaul. And again, my name is Martin Hevesy. This is Cellular and Wireless Unmasked. I appreciate your time watching my video. Any questions, please go ahead and throw them down in the chat. And I love it when you subscribe to my channel for future videos. Thank you so much for watching.